Hope you are doing good. So we will continue with our Indian geography related to general studies. Okay. So yeah, I'm doing good. Thank you. Okay. In the last class, we have seen up to a general introduction about the drainage patterns, and then we have seen the India, the drainage basin, and then the what is a watershed line, all those things we have seen in the last class. So today we will actually go into the drainage systems of India. Okay, if you broadly it is classified into Himalayan system and peninsular system, and then Himalayan in turn it is divided into Indus, Gangetic, and Brahmaputra. These are the three main rivers which are draining the northern aspect of the Indian peninsula. Okay, so Indus, Ganges, and Brahmaputra. We will see these rivers where they start, where they fall into the sea, and then what are the tributaries. If any special attributes we can recollect about these rivers, we will check, and we will also come across some of the drainage pattern which we have already learnt. So then and there, okay, and then we will go ahead and see the peninsular rivers, some of the major rivers, and then we have the comparison between the Himalayan drainage and the peninsular drainage. That is one usual questions which might be asked in in the main GS. Okay, the difference between the Himalayan system of drainage and the peninsular system of drainage. Okay, that is one thing. And then a few more topics we will see, like how the drainage system of the India has evolved geologically, like in the past, how the drainage system has evolved. These are the conceptual part, and to be frank, that the tributaries and where it originate all are factual. You can learn it from any standard text. Okay, even the best way to learn about rivers are Wikipedia. So you will get the map also, you will get the tributaries, any special attributes also, which are all the cities through which the rivers flows through, like that. One day you can open all the rivers in Wikipedia and simultaneously take a notes, and you can finish it in one day, all the rivers. Okay. So that is one way of learning, and another way of learning rivers is like you can draw a tabular column, or you can take an Excel sheet and do this if you are good in using the digital format. Okay, the river name, okay, Ganges, tributaries, left hand, right hand, like that, origining place, okay, where it drains, like that. The column can have other headings like places, important places, then pattern of drainage pattern. What is the pattern usually seen? Okay, so any other remarks, other important points regarding that particular river, like this you can have a tabular column so that you can revise it very easily during the exam time. Just before the exam you can once go through this tabular column, so that you will get the information about all the major rivers in one place. Okay, this is how you should learn and revise the rivers, okay, drainage system. So now we will see some conceptual aspects of the Himalayan drainage. Okay, it is partly because of melting of the snow and partly because of the precipitation. Precipitation, what is the difference between precipitation and rainfall? Rainfall is a part of precipitation. Precipitation includes even the snowfall, other forms of the moisture content being coming to the earth. Frost, snowfall, dew, everything can be called as precipitation. But rainfall is, it is only the liquid format which we are getting as rain. Okay, then they are the perennial rivers. They are the perennial means throughout the year the flow will be there. Throughout the year the flow will be maintained. Okay, they are characterized by deep gorges, V-shaped valley, rapids and waterfalls. I don't know whether I have discussed with you what is a gorge, what is a V-shaped valley. Something like this. The slope of the valley is vertical. Here the river will be flowing. Okay, if the slope of the valley is vertical, then it is termed as gorge. Okay, usually like when I dealt with the Himalaya, I told you about the gorge. Okay, V-shaped valley is, as the name suggests, it is like V-shaped. Okay, V-shaped valley. Rapids and waterfalls also I told you. Okay, if it is continuous next like this, it is known as cascade. Waterfall is a bit with certain amount of height, the waterfall is happening, that is waterfall. Then rapid is a fast moving river. It need not be a fall, it needs to be a fast moving river. Okay, that is rapids. So Himalayan rivers are characterized by deep gorges, V-shaped valleys, rapids, waterfalls. Okay, and then when it comes to the plain, Gangetic plain, they deposits in the valley, and then also while draining into the river they form extensive delta. Okay, these are the attributes of Himalayan drainage. We will go on to see one by one the Indus drainage system. Okay, the Indus originate, sleet, hailstones, snow, rain included in precipitation. Good. Okay, Indus, it originate near the Kailash range. Kailash range. This is Kashmir. We had the Kailash range somewhere here. Indus originate near the Kailash range. Near the Kailash range. The glacier name is Bokar Chu. Bokar Chu. Indus river is known as Singi Kamban in Tibet. When it comes into India, it flows between the Saskar and Ladakh range. Ladakh range. Southern aspect Ladakh would be there, northern aspect Saskar would be there. It cut the Ladakh range. So, like, right, I will take this only. So, it originates somewhere here, Bokarju glacier. When it comes here, the Indus, it cuts through this is the Ladakh range. It cuts through the Ladakh range to form a gorge. Okay, near Gilgit. Near Gilgit. Gilgit is a place. Okay, Gilgit is also name of a river, a tributary of Indus, but it is also name of a place. Okay, near Gilgit, it cut through the Ladakh range and forms a gorge. What are all the tributaries? And then it enter into Pakistan. Shiok, Gilgit, Saskar, Hunsa, Nubra, Shigar, Gusting, Dras. These are the tributaries. On the Indian side, Kurram, Tochi, Gomal, Vibova, Sangar are the tributaries on the Pakistan side. Okay. You might have heard about this Nubra Valley. Nubra where the Nubra river flows, that is the Nubra valley. Dras also you might have heard about. When you are talking about the current affairs in Kashmir, you might have heard about these names. Okay. Shiok, Gilgit, Saskar, Hunsa, Shigar are the, and then Panjanad rivers. Panjanad rivers are the 5 rivers of Punjab. Jhelum, Chenab, Ravi, Beas, Satluj. They also combine and fall into the Indus. They also join and then fall into the, drain into the Indus, Panjanad river. Okay. So we will see the map, how the course is. It originates in the Tibet and then flows between Ladakh range and the Saskar range. It cuts through the Ladakh near Gilgit and forms a gorge. Nubra, Shiok comes and joins, Gilgit comes and joins, and then go into Pakistan. This is the Indus original river. Okay. Sanskar or Saskar is from the, and here itself I will tell you one thing. When you are dealing with a river, many of you might be knowing, but for those who may be new to the field, for those people, if you are dealing with a river, if the river flow is like this, okay, the tributary which is joining, you have to stand along with the flow of the river like this, face the flow of the river and then identify the tributary. This is left hand tributary, this is right hand tributary. You should face the direction of flow, towards which direction the river flow, and then you should name the tributary as right hand and left hand. Okay. So for this river which is flowing this side, Shiok, Gilgit are right hand tributaries, Saskar is left hand tributary. Now we will see the tributaries little bit. Okay, the important tributaries alone. Jhelum. Jhelum, it originate near Pir Panjal, in the foothills of Pir Panjal. Pir Panjal is the lesser Himalayan range. Pir Panjal and Dauladar, you should recollect. Pir Panjal and Dauladar are the ranges which makes the lesser Himalaya. So Jhelum originate near the foothills of Pir Panjal, here. Foothills of Pir Panjal. I told you the Ular lake, Dal lake is the cut-off lake of Jhelum, but Ular lake is, even now it is joined to the Jhelum river. You can see the small blue color dot in the map. That this is the Ular lake, which is very near to Srinagar. Dal lake is like even more closer to Srinagar, but Ular lake is little bit away from Srinagar, but both are related to Jhelum river. Okay, and it feeds to the Ular lake, and the Ular lake overflows and continues as Jhelum, and then it goes and join into the Chenab in the Pakistan. It joins the Chenab river in the Pakistan. Okay, that is regarding Satluj. Then coming to the Chenab. Chenab is the largest tributary of Indus. It originates as two rivers, Chandra and Bhaga. You can see here, Chandra and Bhaga. It originates as two rivers, Chandra and Bhaga. They both join at Tandi, Tandi, the place where Chandra and Bhaga river unite to form Chenab is known as Tandi. Okay. So the river again flows into the Pakistan. That's it. And the origin is in the Himachal Pradesh. Himachal Pradesh. Next river, Ravi. Ravi, it originates near Rohtang Pass. Even the Chandrabhaga also originate near that only. Rohtang Pass. Rohtang Pass in Himachal Pradesh. It flows between the Pir Panjal and Dauladar. Actually, the Pir Panjal and Dauladar will be like this. Pir Panjal range would be like this and Dauladar would be like this. Two ranges. Okay, it flows between the Pir Panjal and Dauladar. Ravi. Okay, so, and then it enters into Pakistan and drain into Chenab again. Regarding Ravi, it originates near Rohtang Pass and flows in between Pir Panjal and Dauladar and drains the valley of Pir Panjal and Dauladar and then flows into Pakistan and drain into Chenab. Then coming to the Beas. Beas, the origin point is same in the Himachal Pradesh only, very near to the Chandrabhaga and Ravi. It originates from the Beas Kund. The place is known as Beas Kund. Beas Kund. Beas Kund in near Rohtang Pass. That the Beas Kund is a small hill near Rohtang Pass. It originates from there and then it cuts through the Dauladar range. It cuts through the Dauladar range and forms gorges. Okay, the Beas cut through the Dauladar range and forms gorges. Two gorges, it forms two gorges. The places are Katti and Largi. Katti and Largi or something, where the Beas form gorges in Dauladar range. Okay, after that, it moves into Pakistan and then join with Chenab. First it joins the Sutlej and then move into the Sutlej goes into the Pakistan. Sorry, Beas fall into Sutlej. So now coming to the Sutlej. Sutlej originate in the Tibetan region again. Rakshasthal. Okay, that is a lake where the Sutlej originate. a lake in Tibet, again near the Kailash range. Near the Kailash range. Okay. When the Sutlej enter into India, this portion, it forms a gorge. It forms a gorge. The gorge is in the greater Himalaya, Himadri range. It forms a gorge cutting through the greater Himalaya when it enters India. The place is Rupar. Rupar, the place where the gorge is formed is R-U-P-A-R. Rupar. And the pass through which it enters is Shipkila. The pass is Sutlej enter it to India through the pass known as Shipkila. Shipkila Pass. Okay. It is an example for Sutlej is a very good. Both Sutlej and Indus are example for antecedent river. We have seen antecedent drainage. Okay, consequent, antecedent, then obsequent, subsequent and all we have seen. Okay, in that this is antecedent. Both Indus and Sutlej, they both are antecedent rivers. They are example for antecedent rivers. They were there even before the origin of Himalayas. Okay, and it is on this Sutlej we have the Bakranangal project. Bakranangal project. Okay, left and right hand tributary. For those who are not able to get it, I am explaining it again. The river is flowing like this. Okay, you have to stand by the side of the river towards which it is flowing and then decide which is left and which is right. Okay, this is my left. So this is left hand tributary. This is my right. This is right hand tributary. The river is flowing like this towards the board. Towards the wall it is flowing means I should stand like this and decide. This is left, this is right. Okay, if I say left, right, should take it. You should stand, you should see the direction seawards, downwards, and then decide the left and right. Some of you are asking because of that. Sutlej and Indus are example for antecedent drainage because they were originating beyond the greater Himalayas, and they form gorges, and the gorges are showing that they are there before, even before the uprising of the Himalayas. Okay, antecedent rivers. Both are antecedent rivers. I will again deal with this antecedent river and all while I am dealing with the origin of the drainage system, Himalayan drainage system. I will discuss what are the theories. Okay, what is the theory behind the origin, how the Himalayan drainage system has originated. Okay, then coming to the Ganga system. Now I have not dealt about the smaller rivers like Gilgit, Shiok, Saskar. These smaller rivers I have not dealt. Please go to your atlas and some text, better Wikipedia, and gather some points regarding the smaller tributaries also. Okay. Like where it originates, where it flows, and to which river it joins on which hand side. Okay, like that. Okay, now coming to the Ganga system. It is from the Gangotri glacier near Gaumukh in Uttarkashi in Uttarakhand. Okay, the river when it was originating, it is known as Bhagirathi. It is not called as Ganga, it is called Bhagirathi. Other river known as Alaknanda. Alaknanda that originate from the Satopant glacier. That is also in Uttarakhand only. Satopant glacier. Here it is Gangotri glacier. Here it is Satopant glacier. Alaknanda meets Dhauli at Dhauli and Vishnu Ganga at Vishnu Prayag. Pindar at Karnaprayag, Mandagini at Rudraprayag. Okay, and then finally Bhagirathi and Alaknanda joins to form Ganga at Devprayag. I will explain it again. Okay. This is Gangotri. Gangotri glacier, and then the river is known as Bhagirathi here. Bhagirathi. Sorry. Bhagirathi here. Okay. Here, this side, it is Satopant glacier. Pant. Satopant glacier. The river is known as Alaknanda. Okay, Alaknanda comes down. It meets two rivers. One is Dhauli Ganga. Dhauli Ganga and Vishnu Ganga. Vishnu Ganga and Dhauli Ganga. The place is known as Vishnu Prayag. This place is known as Vishnu Prayag. Okay. And then the river comes even down. It meets Pindar. The place is known as Karnaprayag. Only blue color is river, yellow color is I am labeling it. And then Mandagini, another river. Mandagini. The place is Rudraprayag. Okay, Rudraprayag. So after all these things, and always after some tributaries comes and fall in Alaknanda, Alaknanda is called Alaknanda only. Okay. After this point, it is known as Ganga. This point is known as Devprayag. I hope it is clear. The previous slide I will show you again. This is the same thing which is there as a writing. Okay. I'll show, don't worry. If you are okay with this, I'll show that slide only. Because this will go once I leave this page. All the blue lines are river and yellow lines are the labeling. Okay, that is done. Then same thing. The slide is also having the same information. Okay, shall we move ahead? Okay, what happens when it goes into Bangladesh side? Okay, when it started, it originated like this. What happens when it comes to the Bangladesh side? In between, many tributaries come and join. That we will deal later. It splits into Bhagirathi and Padma. Bhagirathi is also known as Hooghly. Bhagirathi river is also known as, again, Bhagirathi is also known as Hooghly, which flows through the Kolkata, very near to Kolkata. This river is also known as Hooghly river. Padma enters into Bangladesh. And then Padma and Jamuna joins there in Bangladesh. That we will see little bit later. Okay. Padma enters into Bangladesh. So total 8.6 lakh square kilometers in India is being, this is a basin, drainage basin. The total area drained by the Ganga river, Ganga system of rivers. Okay. And the kilometer, the length of the river is 2525, easy to remember, 2525. Okay. Important tributaries on the right bank, which means from the southern side, Yamuna and Son are the two important tributaries. On the left hand side, left bank tributaries, Ramganga, Gomati, Gagra, Gandak, Kosi, Mahananda. Okay. And then Yamuna is one of the major river. Okay, Yamuna is a system in itself. Okay, major river, westernmost and the longest river tributary, and it originates from the Yamunotri glacier again in Uttarakhand. Uttarakhand, Yamunotri glacier in the Bandeir Panch range, a small range known as Bandeir Panch. That is a range where the Yamunotri glacier is located, and it flows and joins into Ganga at Prayag or Allahabad. Okay, for Yamuna, what are all the tributaries? Right bank from the southern side, Chambal, Sindh, Betwa, Ken. Chambal, Sindh, Betwa, Ken are the right hand tributaries of Yamuna. Left bank are smaller tributaries, Hindon, Rind, Sengar, Varuna are the left bank tributaries of Yamuna. Hindon, Rind, Sengar, Varuna. If you try to memorize in a single day, it will be difficult, but if you are slowly learning, it will definitely come to you. Okay, you will come to know that this Chambal, Sindh, Betwa, Ken and all, it will come as a like a poem, it will come to your mind. This is on the left side, on the right side, like that. Okay, don't try to memorize in a single day, it will be difficult. Okay, that's it. We'll go and check the map. Okay, this is how the Ganga comes down. Okay, when you are seeing here, you need to look at the places also, like Ganga is associated with Kanpur, Allahabad, Ghazipur, Chapra, Baruni, Hasipur, Patna, Faraka barrage anyway you will be knowing. Okay, so like that, when you are seeing map, you should see the neighboring towns also, so that if at all a question is being asked, you will be able to answer that. Okay. So now we will see . One minute. Okay, so some important tributaries in the Ganga system. Chambal river. Okay, Chambal river, it arises near Mo. MHWO is the place in Madhya Pradesh. Mo. MHWO. Mo in Madhya Pradesh. It flows into Rajasthan, and in Rajasthan there is a dam known as Gandhi Sagar Dam on Chambal. And the erosion is erosional activity of Chambal. This is a sort of a old river. Okay, old river because it is draining the plateau, old river. So these tributaries actually they have eroded the land very much. So ravines means highly eroded landforms. ravines. We call it as Chambal ravines. Ravines means it it will be like steep. It will be cut into, the land would be cut into very steep valleys here and there. So it is very difficult to cultivate. Chambal ravines. So it is known as bad land topography. Bad land. It is not easy to cultivate such land. Okay. So bad land topography. The Chambal drained region. Chambal ravines. It is called as Chambal ravines. Bad land topography. Then we will check this river, which is a Gagra. Gagra. It originates from the glacier of Mapcha Chungo. Somewhere it originates from a glacier of Mapcha Chungo. I am speaking about Gagra. Mapcha Chungo. Mapcha Chungo. And it meets Ganges at Chapra. Chapra is the place where Gagra meets Ganga. So Gagra, Chapra. It is rhyming words. Gagra meets Ganga at Chapra. And one important tributary of Ganga is Kali river or Sarda river. This one. Sarda or Kali. This side it is coming and meeting. Okay, you can see the blue line. Sarda or Kali river is an important tributary of Gagra. And then coming to Gandak. Gandak river fall into Ganga at the exact place is known as Sonpar, which is near Patna. The place where Gandak flows into Ganga is known as Sonpar. But that Sonpar is near Patna. Sonpar. Okay. It originate, Gandak originate as a two river, Kali Gandak and Trishul Ganga. Kali Gandak and Trishul Ganga. Okay. And then they join to form the Gandak and join Ganga near Patna at a place called Sonpur. Then this is the Kosi river. One of the tributary of Kosi is Arun river. Okay, you can see the Arun which is coming from the north. Okay, the Arun river is example for again antecedent river. Antecedent river. The important tributaries of Kosi are Sun Kosi, Tamur Kosi. Tamur is coming from east, Sun Kosi is coming from west. They all join to form the Kosi river. Sun Kosi, Tamur Kosi, Arun. They join to form the Kosi river. Okay, so these are the main tributaries of Ganges, and there are some other tributaries like Ramganga, Mahananda and all. Mahananda, it is from Darjeeling. Near Darjeeling it originates and joins Ganga in the West Bengal. Okay, Mahananda, it originates near Darjeeling Hills. Mahananda is from south. Okay, it is a right hand tributary. It joins Ganga near Kannauj in UP. Okay, Mahananda, they are the smaller branches. Okay, I would like you to even find the origin and draining points of Sindh, Betwa, Ken. Son is also one of the important river. What are the tributaries of Son? North Koel is a tributary. So these rivers also you have to check the way I am doing. So any importance is there, that also you should note it down. Okay, then Brahmaputra system. Okay, regarding the Son river, which I have told you, Son river, you may be remembering that it is a part of radial drainage in Amarkantak plateau. That is the importance of Son river. Okay, it is a part of the radial drainage from the Amarkantak plateau. Okay, the Brahmaputra originate in the Tibetan sites. Mahananda originates from the Darjeeling Hills. Okay, Darjeeling Hills from the northern side only. Mahananda originate from the Darjeeling Hills from the northern aspects, and then come and join as a left bank tributary. Mahananda. Sorry, Ram Ganga, I was telling somewhere here, it is here. Sorry, the river is mentioned here. Okay, it is not here. It is Damodar here, Ram Ganga, from the Uttarakhand only. It's a small river from Uttarakhand and join into Ganga. Okay, so we'll take my chat. Mahananda is a left bank tributary only. Left bank tributary only. You are asking me about Kosi. Kosi originate from the Nepal Himalayas. Okay, this region. Arun Kosi is the antecedent river which originate beyond the greater Himalayas. Okay, greater Himalayas. The other tributaries are Arun Kosi is one tributary, Sun Kosi is one tributary, Tamur Kosi is one tributary. Tamur is from east Tamur. Sun Kosi is from west. Okay, they all join to form the Kosi. Then Brahmaputra originated in Chamayungdung Glacier. Chamayungdung Glacier in near Kailash Range and Manasarovar Lake. In Tibet, it is known as Sangpo. The river is known as Sangpo in Tibet. Okay. It forms a deep gorge in the greater Himalayas near Namcha Barwa. Namcha Barwa is a peak in Tibetan region, Himalayan peak in Tibetan region. Okay. After the gorge, the river is known as Siang or Dihang. The river is known as, initially it is known as Sangpo. After the gorge, the river is known as Siang or Dihang. Okay. After it joins the Lohit on its left bank, left bank, it is known as Brahmaputra. The name Brahmaputra is from the point where it joins the Lohit, river Lohit. Okay, major left bank are tributaries are, one is Lohit, another one is Burhi Dihang and Dhansari. Right bank tributaries are Subansari, Kameng, Manas, Sankosh. Okay, I will show the map. It will be clear if I show the map. Okay, we will check it in the map. Okay, so this is the actual Brahmaputra river which is coming. Brahmaputra river coming. Only up to Arunachal Pradesh the map is showing. Beyond this, at somewhere like this point, it curves around the Namcha Barwa and forms a gorge. Okay, forms a gorge. Here it is known as Siang or Dibang. The name is Siang or Dibang. After, you can see that Dibang also. After it joins Lohit, this is Lohit river. Lohit, from this point onwards, it is known as Brahmaputra. After Lohit, it is known as Brahmaputra. And then it comes down. What are all the tributaries? Right hand and left bank tributaries. What is the right? Whatever it is like this, it is right hand. Whatever this side, it is left bank. Okay. Left bank, Lohit itself is a tributary left bank. Burhi Dihang, it is one of the tributary in the left bank. Dhansari is one of the tributary in the left bank. This Kolong is known as Anna branch. You can see the Kolong. It is called as Anna branch. What is Anna branch? A river is there, a branch separates and join again the river. That is Anna branch. Okay, a river is flowing, one river is separating from the river like a distributary and then again going and joining the same river. That is known as Anna branch. Kolong is an example for Anna branch of Brahmaputra. I hope Anna branch concept is clear for you. Now this Dihang or Siang name and all you can call anything, but actually where the Lohit is joining from that point it is known as Brahmaputra. Before that it is Siang. Okay, this Kolong is a Anna branch. It is not a tributary, it is an Anna branch. For that Anna branch, another river is there which is known as Kopili. So Kopili is also a tributary of, ultimately the Kopili water is also drained by Brahmaputra river only. Okay, Kopili is joining the Kolong. Kolong in turn is a Anna branch of Brahmaputra. Kopili. I hope you can see the words. So we will check the northern side are the right bank tributaries. Subansri you can see here. Subansri river followed by Kameng. This is Kameng. Subansri, Kameng. Manas, Shankosh. These are the important rivers. Okay. Other river, this Barali, Barnadi, you can have it, but these are the important branches. Shankosh, Manas, Kameng, Subansri. So what happened in Bangladesh means Brahmaputra goes and falls into, once it enters Bangladesh, it is known as Jamuna. Okay. Once it enters into Bangladesh, it is known as Jamuna. The river is called as, Brahmaputra is called as Jamuna. Ganga, after Faraka barrage, it divides into two, like one is Hooghly, another one is Padma. Hooghly, this is Padma. This river is Jamuna. Jamuna is a name for Brahmaputra in Bangladesh. And then after Jamuna falls into Padma, this is known as Padma only. Okay, actually Padma, and finally it receives another river known as Meghna, important river Meghna in Bangladesh, and then the Padma, here it forms delta Bangladesh. It joins into the Bay of Bengal. Okay, Hooghly also comes and falls here. It becomes a great delta. Okay, the final river which is joining Padma is Meghna. Okay. So you take it down this one. I will write down the names of the small rivers there. Okay. To make it clear, I am removing the small disturbance. Okay. Ganga divides into Padma and Hooghly. Hooghly comes and drains into the sea. It's gone, man. Okay, here you are asking for, you are not able to see. Okay. This is the Siang or Dihang which is coming. The Lohit. This is Burhi Dihang. You can search in Google Brahmaputra river. I have taken from net only. You will get the same map also. Okay. Don't worry. This is Subansri. Nothing big. Okay. Subansri. This is Dhansri. Koppili. Sorry, only one P. Koppili. The river, Anna branch is known as Kolong. This is Sankosh. Manas. Kameng I wrote. These are the major branches. Okay, some of you are asking me to explain the Anna branch again. Okay, this is the river Brahmaputra. One river known as one distributary. What is difference between distributary and tributary also you should know. If a river comes and join, it is known as tributary. If the river divides into two, if the river is moving away from the parent river, then it is known as distributary. This is tributary. Many of you may be knowing. This is known as distributary. If the river is separating from a parent river. Distributary. Okay. One of the distributary from Brahmaputra, the red line is the Brahmaputra, separates from the Brahmaputra and again joins with the Brahmaputra. That river name is Kolong. If a stream or a river or a distributary, you can call it by any name, if it separates from the main river and joins back into the same river, then it is known as Anna branch of the river. Okay, Anna branch of the river. So Kolong is it is not a tributary, it is not a distributary, it is a Anna branch. It is joining the same river. Okay. So this is the concept of Anna branch. I am saying you go to Google and type what? Brahmaputra map. You will get the same image. Some of you are asking me to screen share this. You can take a screenshot if needed. Like I don't have any what? You can take a screenshot if needed from whatever device you are reading. but the same map you will get in the Google. If you are typing Brahmaputra map, Brahmaputra river map, and then go to images, click images, you will get n number of map, even better than this map also you will get in the Google. Okay, coming to the peninsular rivers. Okay, I am being asked by some of you to draw the Bangladesh part again. Okay, in this I will draw. Okay. The river Ganga, after Faraka barrage, it flows down as Hooghly. This is Hooghly. Towards Bangladesh side, it is known as Padma. The Brahmaputra, it enters into, when it enters into Bangladesh, it is known as Jamuna and falls into Padma. And the Padma, during its final course, receive another river known as Meghna. Okay, all drain into the ocean at this point. Okay, so you want me to write this is Ganges, this is Hooghly. Hooghly, or another name is Bhagirathi. L-I, L-Y both are correct. This is Padma. Here it is known as Brahmaputra. Here it is known as Jamuna. In Bangladesh, the same Brahmaputra is known as Jamuna. The last river to join is Meghna. Barak river is a branch of this Meghna. Barak river, which is in the northeast, it is a branch of Meghna. Sorry, I should not say branch, it is tributary of Meghna. It is not a direct tributary again. It falls into Surma. Surma is a, Barak is a important river in this Tripura Mizoram belt. Okay, this here. The name is Barak. Barak river, it joins Surma in Bangladesh, and that Surma joins Meghna, and Meghna joins Padma. Okay. Okay, we will move ahead with the peninsular rivers. Okay, so evolution of Gangetic river, I will take it at last. Here peninsular river. So you know that the western coast is submerging or subsidence coast. Okay, and then upheaval of Himalayas. Himalayas raised, and because of this since the entire plate went and crashed with the Eurasian plate, this belt also, the entire plate also underwent severe faulting. These are the fault zones. Okay, sorry. These are the faults: Tapi fault, Great Boundary fault, Himalayan front fault, which we have seen during Himalayas. The Himalayan front fault is occupied by Gangetic rivers. Okay, here Narmada fault, Tapi fault, Godavari, Mahanadi fault, Koina fault, Kaveri fault. These are the major fault. So all these fault were occupied by the whatever the water, surface water which are collected, were occupied. They started occupying these faults and gaining access to the sea. Okay, so the faulting due to the plate collision and the upheaval that resulted in formation of the drainage system in the peninsula. There is a slight tilt of peninsular block from northwest towards southeast. The tilt, there is a tilt. The slope is like this, northwest to the southeast. You know that, okay? So majority of the flow would be in the same direction. Exception would be this Narmada and Tapi. Narmada and Tapi. So because of that only, when we see the water divide, it will be something like this. The water divide. Whatever water which is falling on this side gains access into Bay of Bengal. Whatever water falling this side gain access into, sorry, this side Arabian Sea, this side it is Bay of Bengal. So this is the geology of peninsular river. So we will see the major peninsular rivers now. Unlike the Gangetic, Indo-Gangetic Brahmaputra system, these rivers are not so complicated at all. It is simple rivers, like it is just origin, where it drains, those things you have to have a note of. Okay. The first river is Mahanadi. Mahanadi rises in Raipur district of Chhattisgarh. Raipur district of Chhattisgarh. And then runs through Odisha and discharge into Bay of Bengal. So nothing. Mahanadi. Then Godavari. Godavari is the largest peninsular river system. Hence it is known as Dakshin Ganga. It originates in the Nasik district of Maharashtra. Here. Sorry. It is the print is not right. Godavari and Manjira should join this side. Okay, not the Krishna. Only the Bhima should join the Krishna. Okay. Here somewhere they have made mistake. Okay, Godavari is the largest peninsular river originate in the Nasik district of Maharashtra. So it flows through tributaries and drainage basin is present in the Maharashtra, Madhya Pradesh, Chhattisgarh, Orissa and Andhra Pradesh. The important tributaries are Penganga, Indravati, Pranita, Manjira. Okay, I'll remove this. You can see the Penganga, Indravati, Pranita and Manjira. I will show. This is Pranita, and then Manjira is this river, which is wrongly shown to join the Krishna. This line will not come. This is Manjira. This is Penganga, Indravati, Pranhita, Manjira. This is Manjira. These are the important tributaries of Godavari. The important project of Andhra Pradesh, Polavaram project. Polavaram project is on this river, Polavaram project. And then the river forms a delta near Rajamundri. After Rajamundri, it forms a delta. And it is very close to Krishna, so it is known as KG basin. KG basin means Krishna Godavari basin. In the delta, it is very close to the Krishna river. So it is known as KG basin, Krishna Godavari basin. Okay. One of you is asking a question. Sir, is it because water divide, there is a split in east and west flowing, or after finding about east and west flowing, they named it as a water divide? All the thing which we do is what we name. Actually, the nature is showing some pattern. Based on that, we are giving some name. Okay, nothing is written on that. Even on the rivers also, no names are being written. It is all water. So the water divide is the imaginary concept which we have done after seeing the flow of the water on the surface water, how the surface water flows are there. Okay, based on that we have framed this idea or concept of water divide. Which came first, whether the divide came first or the flow came first, it is nothing. Both of them developed simultaneously. Because of the divide only the flow is happening, and because of the flow, the divide we are able to identify. It's a chicken and egg sort of a thing. It's a Polavaram project which is in the Godavari river. Polavaram project. It is a river diversion actually. They are trying to irrigation project in the river Godavari. Okay, that much you can take it. You can check. I'm not very sure that from which two rivers they are connecting and what is the exact thing they are doing. It's a river linking project. between Krishna and Godavari. Okay, they are trying to divert some water from Godavari to Krishna, it seems. Okay, by building a dam and a canal which connects the Krishna and Godavari. Okay, but to be sure about the alignment and everything and all, you can search. That is in the Godavari river. Okay, then coming to the Krishna. Krishna is the second largest east flowing river. Okay, I forgot about the break. Yeah, take a break for 5 minutes. We'll get back. Hello. Yeah. So we will continue. So the next major river is Krishna. It originates near Mahabaleshwar. Mahabaleshwar is both a range and sometimes it is also called as a peak. It is a range, it is a plateau, it is a peak. Everything it is. Okay. Mahabaleshwar in in Maharashtra. Okay. Maharashtra. So the Koina, Tungabhadra and Bhima are the major tributaries. Koina, Tungabhadra and Bhima are the major tributaries. This is the Krishna which originate from the, this is not part of Krishna at all. Okay, Bhima, Tungabhadra and Koina, it is some river here. So Bhima, Koina and Tungabhadra are the tributaries of Krishna. And as I have told you, it also forms the delta on the while it meets Bay of Bengal. It drains Maharashtra, Karnataka, Andhra Pradesh and Telangana. And then coming to the Kaveri, next big river is Kaveri. It rises in Kodagu district of Karnataka. Kodagu district of Karnataka. The important tributaries are Kabini, Bhavani, Amravati. Kabini, Bhavani, Amravati. Okay, there is one peculiarity related to Kaveri, because Kaveri alone receives rainfall from both two monsoon seasons. Okay, these rivers receive rainfall only in the southwest monsoon. Southwest monsoon. This Kaveri alone receives rainfall in southwest monsoons also and northeast monsoon also. And relatively, Kaveri is the perennial, relatively perennial, not a seasonal, as seasonal as these rivers. Okay, Kaveri, since it receives rainfall from both northeast monsoon and southwest monsoon, the fluctuation in the annual flow, that is less in case of Kaveri. And then the west flowing river. Two rivers are major west flowing river, Narmada, Tapi. Okay, Narmada, I have already told you, it originates near the Amarkantak plateau. It's a part of radial drainage, Amarkantak plateau. And it flows between Satpura and Vindhya. Vindhya, Satpura. Okay, it flows between Vindhya and Satpura, Narmada. Then it forms estuary. Estuary, I told you, estuary is an erosional. Instead of delta, they form estuary. Here, estuary. And Sardar Sarovar project, it's an important project. It is an irrigation from Hydel project. Hydel project. Sardar Sarovar project is in the Narmada river. Okay. Then Tapi. It originates from Multai. Multai. The region is known as Multai. In Beetul district of Beetul. The district name is Beetul district of Madhya Pradesh. And then it drains Madhya Pradesh and Maharashtra, and this also falls into the Arabian Sea. Arabian Sea. Okay, and another important river is Luni, which disappears into the Run of Kutch. Okay, it flows into Run of Kutch and suddenly disappears. Disappears means it mixes with the marshy region. Okay, the river is no more like specifically visible. Okay, join the run of Kutch. Okay, it originates in the near Pushkar, the place where the Luni river originates is Pushkar. Pushkar is a place near in Rajasthan which is known for camel market. It's a sort of a regular marketplace. And festival, Pushkar festival is also a famous festival in Rajasthan. Okay, near that place Luni originates and drains into run of Kutch. And it is an example for ephemeral river. Luni is an example for ephemeral. MERAL, ephemeral. River can be perennial, seasonal, and even less ephemeral. Perennial means throughout the year the flow would be there. Seasonal means for a particular season it would be there. Ephemeral means even less than seasonal. Okay, very transient. Whenever the rain is there, the river will be there, and whenever the rainwater recedes, the river will be gone. Okay, it is a Luni is an example for ephemeral or transient river. Okay, and that's all about the peninsular rivers. Now, the difference between the Himalayan river and peninsular river, and I have taken this from NCERT only, and NCERT has the chart. Okay, so place of origin from Himalayan mountain and glaciers. Here in peninsula it is either Western Ghats or Peninsular Plateau or the Central Highlands. Nature of flow, it is perennial. Okay, why it is perennial? Because during summer it is fed by glaciers. Okay, during summer it is fed by glaciers, and during rainfall season also it is till the southwest monsoon. Till the southwest monsoon onset, it is fed by glacier. Once southwest monsoon comes, it is fed by the rain. So both from rainfall and glacier they get their water. So they are perennial. Here it is seasonal, depends on monsoon rainfall only. The peninsular river. Type of drainage. Most of the rivers show antecedent drainage and consequent leading to dendritic pattern. I told you dendritic pattern is like a tree. Okay, here superimposed, rejuvenated, so trellis, radial, rectangular patterns are seen. Example for trellis, Chota Nagpur Plateau. Example for radial, Amarkantak Plateau. Example for rectangle, it is Narmada river. Narmada river between Vindhya and Satpura. Okay. Nature of the river, long course. Okay. So headward erosion and river capturing are common. Headward erosion and river capturing common. I will explain this point alone. What is river capturing? I will explain. And meandering is also common. Meandering and shifting of course is common. I will explain these points. What is headward erosion? What is river capturing? What is meandering? Okay. Here in case of peninsula, it is fixed course, well adjusted to the valley. So no complication at all. Catchment, very large basins. Here relatively smaller basins. Age of the river, young, youthful stage. So active and deepening in the valleys. Okay, these are old rivers. I told you about the Chambal and all. Okay, old river, graded profile and have almost reached their base levels. Okay, no more scope for erosion, but in this case there is scope for erosion. Okay, so I need to explain about headward erosion, meandering, and to some point this I will, what is this base level, what is the eroding capacity, that also I will discuss. Okay. Okay, I will take this slide for discussing. One thing is, okay, not getting any slide. I will add a slide. I need to explain headward erosion, river capturing, valley deepening. These points I need to. What is a headward erosion? A mountain is like this. This is one ridge, this is one ridge, okay. And here is a small ridge also here, okay. Some rivers are flowing. One river is flowing like this, taking a course and flowing like this. Another river is starting like this and flowing like this. Another river is flowing like this. Okay, these lines are water divides. The direction is like this. Okay. So what will happen? This river when rainfall happens, slowly it will erode headward also, towards the top also, and this will also erode towards the top, and in the meantime this summit also will keep eroding, will keep eroded. Okay. So sometimes these two branches, this may be having some other source also. They may meet. Whichever side the slope is there, here the line will be cut off. So this will become a separate river, and the initial portion of this river will join with this river. This is known as headward erosion. Erosion happening in the headward direction or towards the top of a hill, that is known as headward erosion. And river capturing is, it will capture the river or a tributary of another river, so that the river which was flowing this way, it started flowing this direction. Okay, this is you will understand this, both this headward erosion and river capturing concept, when I am dealing with the origin of the Himalayan rivers. There I will give with example. Okay, what is this valley deepening? Valley deepening is found in the Himalayan rivers, absent in the peninsular rivers. Okay, the hill is like this. Hill or the plateau or the mountain is like this. The sea level is like this. The water is flowing from here to here. Okay, it is because of the slope Because of the gradient only, the water is flowing because of the gravity. Okay, till what level it will flow? Till it reaches this level. Okay, this level the flow would be very active. This level is known as base level. When it comes to this level, the velocity of the river will be reduced because there is no slope. So the velocity of this river will be reduced. If I ask you a question, one river is flowing like this, one river is flowing like this. The slope is like this. Okay, A, B. Where the velocity will be more? Definitely the river A will be having more velocity because the slope is very steep. Okay, so the velocity will be more. The velocity of the river will be more. Erosion is due to kinetic energy of the flow. Kinetic energy means the energy which a moving body has. The water has some kinetic energy. Okay, kinetic energy is the main reason for erosion. Kinetic energy is equal to, the formula is of mv square. So v square, m is mass, velocity is v. Okay, in case of A, velocity is more. So in case of A, the kinetic energy will be more, the erosion will be more. Okay, because of that, if you see, this is the case of Himalayan rivers. This is the case of peninsular rivers. So the eroding capacity, the erosion capacity will be more for Himalayan rivers. So whenever it is moving, it tends to erode the valley. So down cutting will be more. It will erode the valley. So it will keep on eroding the hills like this. Okay, but in case of peninsular river, already everything is eroded. Now no more. The base level is almost reached. The base level is almost reached. So the erosion capacity will be less. So the valley deepening will not be there. Okay, it is graded. Graded profile means the slope is very gentle. Here it is young and youthful with high velocity. So deepening in the valleys due to erosion. Okay, what is meandering? When it comes to the plain, the river do not have any velocity at all. So do not have any velocity to run forward at all. So it started moving like this here and there. The looping, the wavering flow of river is known as meandering. Okay, the water starts flowing like this, like a wavy pattern. That is known as meandering. The meandering is a feature of peninsular river, not a feature of Himalayan river. Okay. Okay, that's it regarding the Himalayan river and the peninsular river. Now we will see another concept known as river regime. Okay, what is river regime? It is the pattern of seasonal flow in the river. It is a pattern of seasonal flow in the river. Okay. In case of Himalayan rivers, the source is both monsoon and glacial. In peninsula, it is only monsoon. Okay, and it is measured as cusecs or cumex, cubic meter per second. Cubic meter per seconds. Okay, the pattern of seasonal flow. Here in the graph, January to December is there. January, February, say June I am putting in the middle. The red J is June, summer. And that is the onset of monsoon also. Okay, if you see Narmada, Narmada is an example for peninsular river. From January till June, no rainfall, so no flow at all. Suddenly after the monsoon, the flow peaks, and then just after the monsoon, the flow becomes zero again. Similar condition in Godavari also. Till June, no flow at all. And suddenly it peaks after the monsoon, and then it comes to the previous flow during the month of December. But see the Ganga, relatively it is having flow throughout the year. Relatively it is having flow throughout the year at Faraka barrage. But this is also, Ganges is also showing some alignment with the monsoon. Okay, but see here Jhelum. Throughout the year, here also some dip is there, but not like Narmada and Godavari. Okay, throughout the year, some flow is maintained and the lean flow time is very less. November, December, January. From January end only, the flow starts picking. Okay, from January till June, it is glacial. From June to December, it is monsoon. Okay, here also like that. From January, it is glacial. Here it is monsoon. So no glacial part here, fully monsoon only. Okay, this is known as regime, river regime. River regimes, which explains the seasonal pattern of flow in a river. Main, they can ask you. Main question, there can be a mains question based on this river regimes. Particularly they can differentiate between Himalayan and the peninsular river based on the river regimes. You need to explain that glacier, the monsoon, and then the with graphs and all you need to explain. Okay, any doubt so far? Yeah, river capturing, I will come again that. Okay. Yeah, from January to June, almost zero flow only will be there. Okay, there won't be any flow in the river except when during some rain. Yeah, headward erosion and river capturing, I will once again teach you in the evolution of Himalayan drainage. Here you will understand better what is headward erosion and what is river capturing. Okay, what is the origin point of Kaveri? It is Coorg district or Kodagu district in Karnataka. Okay, so how does this the entire Indo-Gangetic Brahmaputra system of drainage has evolved? There are many theories. Single river theory, multiple river theories are the two theories. Multiple river theory is simple, like these rivers, Ganges, Brahmaputra, they were all separate rivers and they were flowing like this. Okay, it is a simpler form of theory. But single river theory is which was largely being accepted. Okay, there were two rivers. I'll show you here. One is Tibetan river. The direction of flow was like this. Okay, Tibetan river, and it was draining into a lake known as Oxus Lake. Oxus Lake. Another river was Indo-Brahm river or Shivalik river. Present day, the Shivalik range, that is the alignment of the river. Okay, that was draining into the Arabian Sea to the Sindh Gulf. Okay, both the river, the direction is from east to west. Understand this. Okay, Himalayas was not there then. Okay, this is a separate plate. On Indian side, this river was there, and the Tibetan side, that river was there. Okay, the two rivers are there and they were draining like this. Now I am going to draw some tributaries. For this river, like this, tributaries were there. These are the tributaries. For this also there will be tributaries like okay. So some tributaries were draining into the parent river. These two rivers were there and the tributaries were draining into the parent rivers. Okay, now the Himalaya started rising up. Which means this portion I am drawing in green. This portion started rising up. Now the headward erosion started. So now we will come to the what is headward erosion. Once again. The cross section I will draw. This is Indian plate. This is the Tibetan plate. This is the Shivalik river on Indian plate. This is Tibetan plate. Tibet. This is the I am drawing cross section, so I am putting it only a point, okay, a dot, because I am drawing the cross section. This is the Tibetan river. This is Shivalik river. In the next stage, what happened? The Himalaya started rising. Like this. Okay. The river was like this and like this. So some tributaries might have been like this. So the tributaries of this river and this river started eroding the Himalayas headward towards the heights of the Himalayas. They started eroding. That is known as headward erosion. Because due to the rainfall, from here also, like the velocity of the river will increase here, because the slope increases, it is steep, and erosion increases in the hills, okay, compared to the plains. So the headward erosion happened. I will magnify this part alone. This is Himalayas. In the valley, here this side it is Shivalik river was there. That side it was Tibetan river was there. The tributaries which was flowing from the hills, that started eroding. This side also it started eroding, this side also it started eroding. And some point of time, after some time, they met. The other region and all, the mountain would be there. How the mountain would be there? The range would be there. Okay. The hill would be like this. And in between one valley would be there. So here the tributaries will be coming. Okay, like this. So slowly this part is reduced. And they established a connection. So because this portion is kept on eroding. This portion which was initially like this, it was eroded and became like this. Okay, and became a gorge. Okay, this is headward erosion. Once because of this headward erosion, this is the Shivalik river. It captured the Tibetan river because this is low lying compared to the Tibet. Tibet is little bit on the higher altitude. So what happened? Instead of Tibet river flowing this way, they started flowing like this. This is known as river capturing. All the Tibetan river, they started flowing like this. And then in the next stage of upheaval, two important phenomena happened. One thing is rise of Delhi Ridge. Another one, fall of Malda Gap. Here one depression came, here one elevation came. Delhi Ridge along with the Aravalli. Delhi Ridge rised. So the rivers got disconnected like this. Okay. So whatever river which was flowing this side, they got disconnected and they took the line this way. Since here a bottom was created, a downslope was created, this side river started flowing into this thing, okay, in the gap, Malda Gap. And whichever river beyond this also came and fell into the Malda Gap, like this, okay. Because of this gap, it was dismembered into three. Okay, now we will go and check the slide. Okay, there was one river known as Oxus. Oxus are the Tibetan river. It was flowing into a lake known as Oxus. And then there was another river, Shivalik or Indo-Brahma river. That was also flowing from this side to into this Arabian Sea. Due to the headward erosion of the tributaries, it captured the Tibetan river. And then this rise of Aravalli dismembered the flow. Okay, since this is raised, this side started flowing this way and this side river started flowing towards the downslope towards the Malda Gap, dismembered into three main drainage system, and that happened due to this Pleistocene upheaval. Pleistocene is the period during which the rise happened. Okay, the Malda Gap was a down slope. Okay, it is a down, it is up. Because of that, it is divided into whatever is beyond this, it went that side, whatever is this side, it came this side, and then the remaining rivers also surrounding this came and fell into the Malda Gap. Okay, so what is the evidence for this theory? It is the Shivalik mountain, which is now, it is having full of alluvial and lacustrine. Lacustrine means river, something related to river deposits. Okay, the present day Shivalik range has full of lacustrine deposits, which means it is a riverine deposit. So from where the lacustrine deposit have come to that Shivalik range, it is from this river, which is known as Shivalik or Indo-Brahma. Okay, now if you see, this is the Indus River and the Indus River system, which came like this. Okay, all the tributaries, everything, Indus River. One river which is flowing like this is Brahmaputra, and other river which are flowing like this is Ganges, Ganga, Yamuna, 3 river. So you need not confuse more than this. You can simply understand that there existed 2 rivers. One on the Tibetan side, which is known as Tibetan River, and one on the Indian side, which is known as Indo-Brahma or Shivalik River. And the tributaries of the Shivalik River, due to headward erosion and river capturing, captured the Tibetan River. The Tibetan River started flowing through the tributaries into the Shivalik River, and then during the Pleistocene upheaval, the Delhi Ridge formation and Malda Fault. Fault is a low-lying region. Delhi Ridge is the upheaval. Okay, due to the gravity, the slope which is formed, the Indus started flowing towards the Arabian Sea, the Ganges started flowing towards the Bay of Bengal. It is dismembered into 3 parts. Okay. So, if at all asked, Shivalik mountains was formed because of further upheaval. Okay, Shivalik mountain originally was the Shivalik river. So when the plate compressed further, even that river deposits were also folded into mountain. Okay, that is a good question. Okay, this region which was Shivalik, in the further stage of upheaval, this region was also raised. Okay, the river moved a little bit on the southern aspect. Okay, this region also raised. This region also raised in the further upheaval. Because of that only this Shivalik is having lacustrine deposits. Lacustrine means something related to river. Deposits which are originating from a river. Okay, that's it regarding the drainage system. We will move on to the next part. Climate. Okay, factors determining the Indian climate. What are all the factors? First thing is the latitude, where India is located. It is in the Delhi Ridge was formed due to the same plate tectonic movements only. Plate tectonic movements, and then the resultant faulting and thrusting only. Okay, you need not go for each and everything. Like if you have personal interest, you can read about geology more, but for the rivers you can restrict with due to the tectonic movements, and then towards the northern side movement of the Indian plate, the Delhi Ridge was created and Malda Fault was created due to that Pleistocene upheaval time. Okay, with that you can restrict. It is what next level of geology. If you are trying to enter the why the Delhi Ridge was created and why the Malda Fault was created, like that and all. Okay, for origin of the the Himalayan drainage system, you can restrict with the Delhi Ridge and the Malda Fault dismembered the river system into three parts. The leftmost is the Indus, the middle one is Ganges, and the rightmost is the Brahmaputra system. Okay, you can restrict with that. Factors determining the climate in India. First thing is latitude. Okay, the location of the India is mostly tropical and subtropical region. Tropical and subtropical. Tropical means between Tropic of Cancer and Tropic of Capricorn, and the subtropical is the next latitude. After 25 to 35 is the subtropical region. So we know that if sun is like this, I am representing, say I am drawing like this. Okay, this is Tropic of Cancer and Tropic of Capricorn. India is mostly located here, this place. Okay, because of that, it depends. Like towards polar, the weather and the climate become cold and moderate. But in the tropical region, it is the tropical climate, which means that the almost it is a humid and hot zone, equatorial type of climate will be there in the tropical region. Okay, so the latitude determines, the latitudinal location of India determines the climatic aspect. And then the Himalaya, you know that Himalaya is a barrier, for the cold winds from the northern aspect, from the polar cold winds from entering into the India. Himalaya is acting as a barrier. Because of that, India is comparatively warmer. And then Himalaya also acts as a monsoon trap. When the monsoon wind comes, southwest monsoon wind comes from the southern aspect, Himalaya blocks that. Otherwise, this monsoon wind will go into the Tibetan side. So Himalaya is blocking the monsoon wind and providing rainfall to the Gangetic Plain region. Okay, Gangetic Plain region. So Himalayas act in two ways. One is barrier for cold wind from north. Second one is monsoon trap. Monsoon trap means it blocks the monsoon wind and gives rainfall to the plains, Gangetic plains. Okay, and then the water bodies, the Arabian Sea and the Bay of Bengal. Arabian Sea and the Bay of Bengal on both sides, how they contribute? They have a moderating effect on the land, that is one thing. And then the southwest monsoon, it is a wind, but the water or a moisture is given by the Arabian Sea. Southwest monsoon is a wind. Monsoon is actually a wind, but the rain is because of the moisture added to the wind by the Arabian Sea. And then similarly in the northeast monsoon also, the moisture is added by the Bay of Bengal. And another aspect is cyclones. Okay, water bodies, what does it does? Moisture to monsoon winds, and then another one is cyclones. They also play a role in cyclone formations, and these cyclones also brings rainfall to the peninsular India, especially the coastal side. And then the distance from the sea, that is also a distance from the sea. When the nearby the sea, for example Mumbai, Kerala, Tamil Nadu coastal region and all, there will be moderating effect of the sea. So the range between the day and night, summer and winter will be less towards the coastal region. But in Delhi, between summer and winter, summer would be around 45 to 50, winter would be around 5 to 10 degree in Delhi. So the difference is 45 minus 10, almost 35 degree difference is there between summer and winter. If you take Chennai, summer would be around 45, winter would be around 25. So only 20 degree difference. Okay, even less than that. If you take Trivandrum and all, the range would be like summer would be 35 to 40, the winter would be 30, 25 to 30. So the range would be 10 to 15. Okay, the range is very less in case of coastal region, but in case of interior places like Delhi, the range of temperature between summer and winter will be very high. That is distance from sea. Then altitude, that also cause difference in the climate of a particular region. For example, Agra and Darjeeling. Agra and Darjeeling are in the same latitude. Okay, almost they are in the same horizontal line, but because of the altitude difference, Darjeeling is located at a higher altitude on the hill. Okay, the January temperature would be 4 degree centigrade in Darjeeling. Here it is 16 degree centigrade in Agra. Okay, it is because of the altitudinal difference. And then the relief. Relief is the nature of the land. Okay, for example, what is the relief? If you take the Western Ghats, plateau, plain, Eastern Ghats, okay, like this. Okay, so southwest monsoon gives rainfall to this slope, the western side. To the Kerala coast it gives monsoon, but towards Tamil Nadu coast, here it becomes dry. Okay, based upon which side of the mountain you are in, windward side or leeward side. This is windward side of a mountain, this is leeward side. This side you get more rainfall, this side dryness. Okay, that also determine the climate of a particular region, the relief. Okay, and you know the Rajasthan desert being contributed by the parallel nature of the Aravalli hills, because it is not able to block the monsoon, so there is no rainfall in the Rajasthan region and we get desert. Okay, because Aravalli ranges are parallel to the monsoon winds. Okay, now we will check the seasons. What are all the seasons in India? Okay, hot weather season. So mostly this is the summer season. up to 48 degrees centigrade. The weather can reach up to 48 degrees centigrade. Here it is July month. It is mentioned July month. Reach up to 48 degrees centigrade. It is summer, okay, hot weather season. If you see here, the coastal region, it is 20 to 25 degrees centigrade. On the east coast, it is 30 degrees centigrade in the summer. Okay. But this region, which is high in latitude, okay, this is also experiencing 30 degrees centigrade. Okay. This is because of the ocean, the southern India is facing mild summer compared to the North India. South India is facing mild summer because of the moderating effect of ocean. So, the coastal region, the isotherms are parallel. Isotherms means line joining the places with similar temperature. Okay. The coastal region, the isotherms run parallel. Here also it runs parallel to the coast. Okay. There is no much difference between this point and this point in temperature. That is because of the moderating effect of the sea. Okay. What would be the pressure and wind? Since the summer is here, due to the high heat, the air mass, the air which is present here will be heated and that will rise up. So, low pressure will be created within the land. During summer, low pressure will be created within the land. Okay. Lu is a type of wind. It is a dry, hot wind blowing in the northern India during the summer season. Summer season in UP Bihar region, Lu is the dry, hot wind which will be blowing, and it can create dust storms in the evening. These are the characteristics of summer season in India. Okay. Some of you are still in meanders. Okay. I think that Himalayan rivers also form meander, especially the Ganges at the last part, and then the Brahmaputra can form meander because they are flowing on a perfectly plain region. Okay, plain region, and meander in Himalayan rivers. Okay, especially the Brahmaputra river shows some meandering. The Brahmaputra river, because they are flowing in a plain region, and due to the huge amount of deposits from the hills, it brings the deposits. Whatever the eroded material that is brought down and deposited in the plains, and that causes the meandering. Okay, meandering, and that is seen in the Himalayan rivers also in the plain region. Sorry, in the plain, that too just before joining into the sea. Okay, in Brahmaputra river, the meandering is so common. Okay, but meandering as such, it is a topic which needs to be covered as a part of geomorphology, physical geography, geomorphology, why meandering happens, how meandering happens, and all. Okay, so meander happens in Brahmaputra river. That is the part of Indian geography. It's a big topic, like how meander happens, like what is the dynamics of the flow which causes the meander is a topic in itself. Okay, I will take another 2-3 minutes cold weather season. Similarly, cold weather season, which is during the mid-November. Here during cold weather, during the cold weather also the southern peninsular region is moderate. Okay, see here again 20 degrees centigrade, 25 degrees centigrade, but north it reaches up to 15 degree, 10 degree and all. Okay, 15 degree, 10 degree and all. The North India and Central India reaches to, but not so pronounced in peninsular India due to the moderating effect of the sea. Okay. One thing is continental, whichever the away from the sea, they experience more cold compared to those who are near the coast. And again the Himalayan snow, the snow formation is also happens during the cold weather season. Okay, and the same snow will get melted and contribute to the flow of the rivers. Okay, and then cold wind from the west, that is also common feature. Okay, cold wind flows from the west into the central India, central and north India. That is also common phenomenon in the cold weather season. Okay, pressure, how the pressure would be there. In contradiction to the summer, we experience low pressure. Now in the winter we experience high pressure in the north. High pressure in the north. Okay. Wind is westerly wind. From this side the wind starts flowing. Okay. In the cold. That is the northeast trade wind sort of a thing. Then rainfall in the cold weather season. Rainfall in the cold weather season. Sometimes like from the Mediterranean Sea, some of the rainfall from the Mediterranean Sea can be brought into India by the westerly wind. Westerly wind can bring some rainfall from the Mediterranean Sea. Temperate cyclone which is happening in the Mediterranean Sea, that can be brought into India by the westerly winds. That is known as western disturbances. Western disturbances. Okay. So then during the October-November, northeast monsoon sets in and gives rainfall only to this region, because only the wind which is blowing into this region is fed by the Bay of Bengal moisture and then gives rainfall to that region. Okay. So after this it is monsoon. We will deal it in the next class. Monsoon, natural vegetation, we will have it in the next class. Okay. Sir, Western Ghats act as a barrier against surface ocean water. Is it a factor that determines the climate in central peninsular India? Surface ocean water is not a barrier. Like, how come Western Ghats is a barrier to water? Okay. Still one of you is asking for river capturing and headward erosion. River capturing and headward erosion, you need not explain in the exam, because all geography examiner will be knowing the concept of river capturing and headward erosion. The only thing you need to do is, you need to understand what is headward erosion and river capturing. Headward erosion is nothing but erosion of the mountain towards the top by the river or its tributaries. Okay. searching for. So this is a mountain, a river which started flowing like this. Okay, if it starts eroding the mountain from bottom towards the top of the hill, okay, towards the top, towards the head side of the mountain, if the erosion is happening, and because of that the river length is increased. Earlier the length of the river is like this, length is say 10 kilometer. Now due to this addition of 2 kilometer headward erosion, it has become 12 kilometer river. Okay, this is known as headward erosion for your understanding. Okay, this is happening because of the slow eroding property of the river towards the headward side. Okay, so headward erosion will result in lengthening of the river. The length of the river will be increased. So in meantime, if any other river is here flowing, there is a possibility that that river will be captured. Captured means instead of flowing that side, it will come and join this side. Earlier the direction of flow might have been like this. So now since it has captured, it will come to this side. Okay, that is river capturing. Simply if you are writing headward erosion and river capturing, the examiner will understand. You need not explain what is river capturing and what is headward erosion. It is for your understanding. Even after this, if you are not able to understand, please go to YouTube and type headward erosion river capturing animation. There might be videos, you can check it. If possible, in the next class I will show you one. Okay, remaining things we will check in the next class. So even this the climate related slides I will revise once and then I will go to the topics. Okay, thank you, see you all.